The first problem you had, 3/2 x equals 16. And to solve this one, when you have an equation and your variable is being multiplied by a fraction, you would divide by that fraction, which means you multiply by the reciprocal of the fraction. Okay, so I'm going to multiply the left by 2/3, and I'm also going to multiply the right-hand side by 2/3. These cancel. Okay, and then what I'm left with is x is equal to 16 times 2 is 32, and then my denominator is 3. So that's why our correct answer is, it shows in the yellow box right there, 32/3, 32/3. Your next one here says, oh, and I am recording this, so you can go back and rewatch this review if I go too fast, okay? So don't stress out if I go too fast. I'm recording it, I'm gonna post it, and then you can go back and rewatch it, because this is gonna be a really good way for you to study for your test that starts tomorrow. Adam bought A apples for $1.50 each and B bananas for $2 each. He spent $1.50 A plus $2B. And then you had to go through and figure out if it's true or false. The variable A represents the price for apples. That's false. A represents the number of apples. Second one, the expression 1.50A plus 2B represents the total cost. Yes, it does. The term 1.50A represents the amount Adam spent on apples. That's absolutely true, because 1.50, that's the cost of one apple. A is the number of apples, so when you multiply that together, you get the total cost just on apples. The term 2B means Adam bought 2 bananas. No, it does not mean that. The term 2B means that each banana costs $2, and however many bananas he bought, you multiply it. It's the total cost of bananas. Third one, Juliana is going shopping for shoes and has a budget of $80. If she buys one pair of athletic shoes for $35, how many S pairs sandals can she buy at $10 each and still remain within her budget? You have to first write an inequality. Okay, notice inequality is in all caps. To help you remember, you need to use one of those inequality symbols. It's not an equation, it's an inequality that models the situation. So we know that her budget is 80. And so in the correct answer, you see 80 is on one side of the inequality. So the amount that she is spending has to be less than or equal to 80. 80 is her budget. And then the amount she spends, well, she spends 35 on one pair of shoes, 35, plus we want to know some number of sandals, which is the unknown variable S, at $10 each. So plus 10 times S. This is the inequality you had to write to get it correct. And then the second part of this was to solve it. And so I'm going to solve that with you guys. So right here on our Jamboard, I'm going to write out our equation of 35 plus 10s is less than or equal to 80. Okay, and now, you know, if you get stuck on solving inequalities or equations, one thing you always do is box and wall, just to help you remember the thing you got to get by itself. And you should do the both sides of the equation. You should do the same exact thing. So my first step here is going to be to subtract 35. I'll do the same over here. That goes away. And that leaves me with 10s is less than or equal to 80 minus 35 is 45. Now, whenever you do something to an inequality on both sides of the equation, you always have to pay attention. If you multiply or divide by a negative value, you have to flip your sign. My next step here is to divide both sides by 10, which is a positive value, so I don't have to do anything to the sign. It's going to stay exactly the same way. It's going to keep it as less than or equal to. The 10s cancel. S is less than or equal to 45 divided by 10. So this is going to give me a decimal. Okay, It goes in 4.5 times, basically, 4 5/10. And well, you can't buy a half a pair of sandals. That doesn't make a lot of sense. So the number of pairs she can buy is 4. Okay, she doesn't have enough money to buy 5 pairs, but she does have enough money to buy 4 pairs, 4.5 pairs, but that doesn't really make sense when you're buying shoes. So we can only use the 4. That's where this answer of 4 came from. 4. Okay, next one, explain the steps used to solve the equation below. So you have an equation that's being worked out on the left-hand side, and then you had to choose what was happening that would describe it. So to go from this equation of 2x plus 2 times the quantity of x minus 10 equals 28 to the line below it, it changes, okay? So it turns into 2x minus 20. That changes because we're using the distributive property. Okay, so number 1 box is distribute 2. This is distribute 2. I can't click and drag these because this is just the answer key, but they are numbered out so you can see they make sense. So first step, distribute 2. Second step, what do I do to go from this line of the equation to this line? Well, it looks like what's changed is 2x plus 2x turns into 4x. That would be combining like terms. Number 2, combine like terms. Next, to go from 4x minus 20 equals 28 to 4x equals 48. Well, I no longer have this minus 20, and the 28 changed to 48 because we added 20 to both sides. 3 is 20, add 20 to both sides. The next step, 4x equals 48, divide by 4 on both sides. The last step, check answer. Okay. Then you have these ones here, determine if the following represent a function. So when we learned about functions, if you guys remember, we talked about something called the vertical line test, where if you have a graph, a picture of something, and you want to know if it's a function, imagine a pencil going vertically across, and you want to think, does it ever touch my graph in more than one spot at any one time? If it does, then it fails the vertical line test and it is not a function. So this first image where this red, like on its side palabra, it fails basically everywhere. Okay, it's always touching the line in 2 spots as you vertically slide your pencil across, except for maybe right at the point where it's at. Looks like that might be -5. That's the only time where it's only having one x value. So this fails, it is not a function. The second one, you have this V-shaped graph. Well, this is not linear, because remember, linear means a straight line, but they're not asking us that. They're asking, is it a function? And a function means that each x value is unique, all right? It passes the vertical line test. It only ever is touched once by a pencil, going side to side, so that is a function. When you're given a table of values, like we have here, this XY table, if you look at your X values, check to see, do any X's repeat? If they don't, well, then you're good, it's a function. Okay, so that's why this is a function. All the X's are unique. 1, 4, 5, and 10, all different. And then we have set notation, which is a bunch of ordered pairs. We have 4 of them. Again, check your X values. 1, 1. Well, right there, I have a repeated X value. That's a problem. The only time it's not a problem is if it maps to the same Y value. So if it was 1, 4, and then again 1, 4, I'd be okay, but it's not. It's 1, 4, and 1, -4. I have X going to 2 different Y values. That is not okay in a function, so that's why it is not a function. Okay, so, and then for the function, they're telling us it's a function. This is the next question. In set notation, we have 1, 2, 3, 4 ordered pairs. We need to find the domain and find the range. This is in your notes. When you find the domain, it's all the possible x's. The range is all the possible y's. So in an ordered pair, you always have x comma y. And maybe that would help to kind of just show you that on the Jamboard here, okay? Every ordered pair is just like this, x comma y. And so these values represent the domain, whereas the y values represent the range. That's supposed to be an N. I like the stareable, sorry. Little better. Okay, so domain and range. So all my x's are -1, 3, 1, and 0. And that's why it shows you here the correct 1 through 4 is -1, 0, 1, and 3. Okay, so they have all the x values on there first. And then the range is all the possible y values. So if you look at your y values, you have 2, 3, 5, and 2. When a number repeats, we don't have to write it twice. Okay, and so that's why it's saying 2, 3, and 5 are the 3 possible ones. And I know it's a little bit difficult to, I think, to kind of process that because you're not clicking and dragging in this image, but I do want to show you what that would look like. Okay, so just if I was to write out the domain, we have -1, 3, 1, and 0. And typically what you would do is put them in order from least to greatest. So I would then rewrite this as -1, 0, 1, 3. And that's kind of what they show you here, -1, 0, 1, and 3. So my domain is those values. Actually, this should be set notation. And then the range is all the possible y values, which are 2, 3, 5, and 2 again. Put them in order and don't repeat. So 2, 3, 5. Okay, that's how you find domain and range. That just kicked me out. Okay, I'll go back in. No problem. I've had it open too long. I didn't like that. Okay, so this is right where we were, finding the domain and range. The next problem we're going to look at says use the graph to find f of -6. Okay, and so basically when x is -6, what is y? So you go to where -6 is on the x-axis, and then you go to the blue line, and you can see my y value is then -8. That's why the answer is -8. The function f of x represents the total amount Michael earned in dollars from working x hours. Interpret the statement f of 5 equals 75 for this context. Well, Michael worked 5 hours and made $75. That's what that's showing you there. X hours. Okay, so 5 is x, so f of x becomes f of 5. All right, and then we're saying he did make $75 from that. This one here, the charge in dollars for cab rides in one city is modeled by f of m equals 5 plus 3m, where m is the number of miles traveled. What is the charge for a 3-mile ride? Well, m is what our 3 is going to be. And so if we look at our whiteboard, clear this out. Okay, so f of, and instead of m, I'm going to use 3, which means when I put in the function here, instead of m, I'm going to actually put a 3. Okay, and then you just simplify that expression. 3 times 3 is 9. You always multiply before you add. Okay, so 5 plus 9, or 14. And that's where this 14 came from. All right, ASB is selling wreaths to raise money for t-shirts. They need to make $50 to buy enough t-shirts for everyone. Door hanging wreaths cost $10 each. Table wreaths cost $5 each. Let y be the number of table wreaths sold and x be the number of door hanging wreaths sold. Okay, so we have two different variables. And y is the ones that cost $5. X is the one that costs $10. Graph the x and y intercept and connect them with a line. Okay, so what you had to do is figure out that the y-intercept is 0, 10, because y is the number of table wreaths. I feel like that problem got mixed around, because if table wreaths, they say they're $5 each. Yeah, I feel like this one's backwards. So that might be an issue. So just kind of, I'm going to just scratch that one for right now, okay? That might be a mistake. Let's just move on to the next one, okay? Mr. Smith brought a jar of once-a-day vitamins for his 2 children. The number of vitamins in each jar is graphed below. Fill in the blanks to best complete the interpretation of the x-intercept and the graphed function. So you're given this picture, and the x-intercept is where the line crosses the x-axis. So it's right here. You can't see my mouse, can you? Or yeah, you can. Okay, so right here between 20 and 30, which is 25, okay? And vitamins after blank days. So 25 is the number of days, and we're here where the value of vitamins is 0. So 0 vitamins after 25 days. Use the table below to determine whether the equation y equals x squared plus 3 is linear. Then choose the words that correctly complete the sentence. Okay, so you're given a table of values, x and y. X is 1, y is 4, x is 2, y is 7. You're also given the equation y equals x squared plus 3. So this function is not linear. One way you can tell is that you have a squared on the x, okay? That's never going to be linear. And a constant change in x does not correspond to a constant change in y. So the x's are going up by 1 each time, where your y values, 4 goes to 7, we're adding 3. 7 goes to 12, we're adding 5. 12 goes to 19, we're adding 7. So it's not a constant change. It is not linear. Given the equation negative 6x plus 4y equals 36, find the x and y intercepts. Okay, so that's where you just set, you take your equation. And to find the x-intercept, we're going to set y equal to 0. So I replace the y with 0, and I multiply it by 4. That term just drops out. And so I end up with negative 6x equals 36, or x is equal to negative 6. Okay, and that's why number 1 is negative 6. For the y-intercept, we're going to start by replacing x with 0. Okay, plus 4y equals 36. Again, anytime you multiply by 0, that term drops out, so we just get 4y equals 36, or y is equal to 9. And that's where the 9 came from on part 2. Okay, so those are the values that would go in those blanks. Use the graph to find the slope. You can count. So let me do this real quick. I'm just going to screenshot this and open this back up. All right, so I just screenshotted the same problem on here because it'll let me draw on it. One thing you can do when you're trying to get slope is imagine you are doing rise, 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 rise until you're even with it, and then run, 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 and over. So it makes this right triangle that you can count the rise and the run. Sometimes a little tricky to count it, especially on this graph, because you were going by increments of 5. This point isn't perfectly lined up with the grid, you know, on either one. So this would probably be a good time to use the slope formula. M is equal to the change in y over the change in x. So my y values are 49 and 10. So if I do 49 minus 10, that'll give me the change in y. And then I'm going to subtract my x values in the same order. So 18 minus 5. Okay, so I'm taking the 18 and the 5. And then if I simplify this, 49 minus 10 is 39. 18 minus 5 is 13. And, well, yeah, that simplifies all the way down to 3. Because 13 goes into 39 3 times exactly. And that's where the answer of 3 came from here. Okay, I lost my... All right, so we're back here. We're almost through all of these. We have till 11:40. We'll get through them all. And then, like I said, I know I've gone a little bit fast, but you can go back and rewatch this. So the graph shows how long it takes Stephen to walk home from school. Choose the numbers that best complete the interpretation of the rate of change for the given situation. For every blank hour, Stephen walks blank miles. The rate of change. We're talking about slope. Okay, so you can look at time. If you start at 0 hours, deny. Why does this person keep trying to join our meeting? I don't know who they are. And basically, you know, for every 1 hour, how much are you moving? Okay, so from 0 to 1, looks like we went from 12 to 8. So for every 1 hour, you go 4 miles. Determine if the following points are solutions for the equation. Okay, 3x plus y equals 10. So easiest way to do these kind is to just substitute in the values. So you start with 3x plus y equals 10. And then, you know, for this first one, -4 and 3, if I replace x with -4, and I replace y with 3, the question is, does that equal 10? I don't know. It says it's not a solution, so it's not going to work. This is -12 plus 3, which is, in fact, not 10. So it is not a solution. Whereas if I choose the next one down, 3 times 4 now, plus -2 instead of 3, then if I simplify this, 12 plus -2, well, the question is, does that equal 10? That is the question. Does it equal 10? 12 plus -2, yeah, that does equal 10, so that one does work. Okay, so you're just plugging in and checking on those ones. Solving the inequality. Remember, guys, when you graph an inequality, you got to graph the equation first, and then you decide, is it a solid line, dashed line, and which side you shade on. This looks like we didn't have the option to make it a dashed line, did we? Or maybe we did. It's showing the wrong solution. Okay, so y is less than 2/3 x minus 4. So, oh, that's just a generic line. That's why. Okay, so here's our solution. That makes sense now. It's like, that is not that equation. Okay, so anyhow, let me just clear this out so we can all see it at one time. Y is less than 2/3 x minus 4. We're going to scroll this up to the actual graph of that, and I'll show you why it is what it is. So your y-intercept is always this. That tells you where to start the graph, and that's why it crosses at -4 on the y-axis. Your slope is whatever is in front of the x term, 2/3. So for every rise of 2 units, I run 3. Rise 2, run 3. Rise 2, run 3. And then because of the symbol, it is a dashed line. And because y is less than, we have to shade below it. Rewrite the equation in slope-intercept form. So this is initially in standard form. Okay, and it's always the same two things when you're taking standard form and going to slope-intercept form. You're going to start by moving the x term to the opposite side. That's step one. Okay, so I'm going to rewrite this as 5y. And then when I'm deciding which term to write first, I want slope-intercept form means I have to put the x term first and then the constant second. That's always the first step. And then the second step would be to divide by whatever's in front of the y. And then make sure you do the same thing over here. Okay, so those cancel, and I'm left with y equals -4 fifths x plus 2. Okay. And you can see y equals -4 fifths x plus 2. So we did that one correctly. And create an equation for the line with a slope of 1/2 that passes through the point -6, 1. So this is point slope form, okay, where it's y minus the y coordinate, which is 1, equals the slope 1/2 times the quantity of x minus the x coordinate. And the reason that those signs are the way they are is because when you are working with two negatives, like a minus and negative, it becomes add the opposite. So what they started with was y minus 1 equals 1/2. And then we had x minus, well, -6. Okay, this right here is why we can see the plus, because it becomes adding 6 instead. That's where that plus sign came from right here. Graph the line. The y-intercept is -8. No, what's this asking me? Graph the line. What line? That line? Maybe they meant that line. This looks like it's a combined question. That would make sense, yeah. So we know we have this point, -6, 1, which is why -6, 1 is right here. There's a point there. And then using the slope of 1/2, we can rise 1, run 2, and make a second point. You have 2 points. That is all it takes to make a line. Create an equation for the line with a slope of 3/5 and a y-intercept of -8. Slope-intercept form. Y equals mx plus b. Y equals 3/5 x minus 8. And then graph that line. So we're going to start at -8. And then we're going to use our slope of 3/5 to rise 1, 2, 3, and then run 5 and make your second point. That's all you have to do to graph a line. This person really wants to join our meet. Okay, are we almost through this? We're almost there, guys. And we have 10 minutes. We're going to make it. Which of the following represents an equivalent form of the equation y equals 2x plus 7? Oh, so that's a little trickier. This is your correct answer. Okay. What's all-in-one Otis thing? The all-in-one Otis thing? I don't understand that question. You can elaborate if you want to. The given equations all represent the same line. From which equation can you read the y-intercept? So slope-intercept form is the only form that lets you read the y-intercept. So I'm guessing, like, I know how to do this problem, but I don't know how to do it like easily. Like you would think it'd be like an easy answer if you're just having to pick it out. Like I could show you a more complicated way to do it. Y is equal to 2x plus 7. So that's slope-intercept form, which means I know the y-intercept. The y-intercept is 0, 7. So this is a point on that line. And the slope is 2. So if I am trying to write the slope as we know it's 2, but we also know it's we're saying, like, is this, like, would this actually work? Okay, y and x, so -3 and +1. So basically, does this point and this point give me a slope of 2? Which is a little bit confusing. I don't really like this problem. Okay, so 7 minus 0, no, 7 minus 1, and 0 minus -3. This is 6/3, which is in fact 2. So it does work. That's one way to do that problem, but that's probably not the neatest way to do that problem. Determine whether the following graphs and tables represent an increasing or decreasing function. So look at the slope. Is the slope negative? If it is, it's decreasing. For part B, look at the slope. Is it positive? It is, so it's increasing. Here we don't see the slope jumping out at us, but check as the x values increase. See how the x's are going up by 1? What's happening with our y values? They're going up by 2, so that's increasing. As the x increase by 1, the y values are decreasing by 1, so this is decreasing. Graph the line represented by the table of values. Okay, so you're just going to plot the ordered pairs, those 3 ordered pairs, we plot them and connect a line through them. That seems relatively easy. That's the last one. Okay, so there was one that I was a little bit confused about in here with you guys, and I want to go back to it. It's this one here. Okay, so we're graphing the x and y intercept and connecting them with a line. I don't really like this problem. You know, maybe if I write an equation, it'll make more sense. Even math teachers don't like all the problems. So, okay, so we have an equation, and basically, I feel like it's standard form. Y is the number of table wreaths, which are 5y plus 10x. Okay, and we want that to equal 50. So I'm just taking information out of the equation. And then getting the x and the y intercepts. So that's where you take turns setting things equal to 0. If I replace the y with 0, I get 5 times 0 plus 10x equals 50. Okay, which is then just 10x equals 50, or x equals 5. So when, this is one of our points, 5, 0. If x is 5, y is 0. And that is what we have, huh? Yep, 5, 0, that's right there. Just seems so weird to me. Okay. And then the other one, we're going to take 5y plus 10 times 0 equals 50. Okay, so those cancel out. You're left with 5y equals 50. And then y is equal to 10. And so that's the other point where x is 0 and y is 10. So these are the 2 ordered pairs that are plotted on this graph, 5, 0 and 0, 10. Just seem weird, but it's correct. And then once you plot the 2 ordered pairs, you connect it with a line. All right, so we did go through every single problem. Do you guys have any questions? And like I said, this is being recorded, so I'm going to post it. You can watch it again and like jump to any part of that if you want to see that again, if that's not something that makes a lot of sense to you. Yeah, I don't know why that kid keeps trying to join our meet. Like, he tried to join like 5 times. I don't know what that is. They're not even in Hemet. Okay. Well, that was a lot of talking. thank you for staying on and paying attention. You guys are all on the meet. I can see what you're doing. Okay, so I'm going to post that video. Test starts tomorrow. Make sure you have all your notes. You can use those to help you. I'll be watching you take your test through GoGuardian. So you just need to be logged in through your Chromebook. There will be a link to get there. So like if you go here, this will turn into a hyperlink. Okay, tomorrow you'll be able to just click this, and then it's going to take you to our test. Okay, I'll have the Otis link. You sign in with Google. It'll be there. You'll start it. You can use calculators. You can use your notes. You can use your textbook. You can't use other websites, outside websites. You can't do that. All right. That's it. You guys are good to go unless you have a question. You're free to leave. Have a great day.